Welcome to The Explainer. I'm so excited to have you with us today. Look, if you've ever watched one of those massive water tank trucks rolling down the highway, or maybe putting in the work on a construction site and thought, man, what exactly makes that thing tick? Well, you're in the right place. Today, we're diving into a definitive, top-to-bottom bias guide that's going to totally demystify the mechanical complexities of these absolute workhorses. We're talking the specs, the science, and the strategy behind them.
Okay, let's dive into this. A lot of folks look at these vehicles and, they just see a giant metal container rolling around. But in reality, a water truck is way more than just a tank on wheels. It is a highly specialized, precision tool. And this is a big catch, that's only true if you spec it right. Picking one of these out is a high-stakes, highly technical decision. Get it wrong, and you're bleeding thousands of dollars in inefficiencies. But get it right, you're deploying an absolute powerhouse of productivity.
So, to get a handle on how they actually work, here's our roadmap for today's explainer. First, we'll hit the core water truck components, then primary industry applications. Third, we're decoding payload and capacity. Fourth, comparing tank materials. And finally, we'll wrap up with pumps and spray systems. Let's get to it! Starting right off with Section 1, core water truck components. Basically, the anatomy of the beast. Now, the very first thing you notice is obviously the tank itself, right? And its shape is incredibly important. You're generally looking at two choices here, cylindrical or elliptical. Now, while cylindrical tanks are your standard traditional shape, going with an elliptical tank is a very deliberate structural choice. Because it's oval-shaped and wider at the bottom, an elliptical tank significantly lowers the vehicle's center of gravity. Guys, this is a total game changer for driving stability, especially if you're out there navigating uneven, unpaved roads or taking sharp turns. It's a design choice that literally impacts operator safety.
And that actually brings us to a fascinating, kind of hidden physics problem. Think about this for a second. What keeps a sudden slamming of the brakes from just flipping a fully loaded water truck? I mean, you've got thousands of gallons of liquid in the back. If the truck stops suddenly, all that liquid wants to keep moving forward. A massive sudden weight shift like that could easily snap a chassis or cause a complete rollover. No way you want that.
And this brilliantly illustrates the solution, baffles. Inside the tank, you've got these interior steel partition walls. They have specific holes cut right into them. So when the truck accelerates or slams on the brakes, these baffles actively slow down the water's movement. They break up the energy of the wave, stopping those dangerous liquid surges and massive weight shifts dead in their tracks. It is such a simple, brilliant structural solution to a seriously dangerous physics problem.
All right, let's look at how this builds our powertrain flow. How does the water actually get out of the tank with all that force? Well, it's a beautifully linear four-step supply chain. Step 1 is the vehicle's engine, which generates the raw power. Step 2 is the PTO, or power takeoff. This is an absolutely crucial component that literally links the truck's transmission to the pump, transferring that engine's mechanical power directly. Step 3, that power drives the heavy-duty, high-capacity pump. And finally, Step 4, the pressurized water is forced out through the spray nozzles. Speaking of those nozzles, they have highly specific jobs depending on where they're mounted. Front-mounted nozzles? Those are strictly business for washing dirt and debris off paved roads. Rear nozzles, on the other hand, are designed to spread water over a really wide area, which is absolutely perfect for dust control. And then you have the heavy artillery, the rear platform water cannon. This bad boy gives operators high-pressure targeted cleaning, long-distance irrigation reach, and even lets the truck provide basic fire support. Moving on to Section 2, primary industry applications. Let's talk about putting the truck to work. These precise configurations are built to conquer some very specific real-world challenges. In construction and mining, they are totally essential for grounding OSHA-regulated dust, which usually requires a high-clearance off-road chassis. In municipal cleaning, those high-pressure front sprays push debris right to the curb for the street sweepers. In agriculture, they're lifesavers, supplying water to remote crops, new trees, and livestock. And they even serve as vital backup support, bringing large volumes of water to rural areas that might be missing fire hydrants entirely. Next up, Section 3, decoding payload and capacity. This is the weight reality check. Okay, here is a stark numerical reality check for you. 1,000 liters of water weighs exactly 1 metric ton. Water is incredibly heavy cargo. When you're talking about a tank holding thousands of liters, that sheer abstract weight suddenly becomes instantly relatable and honestly incredibly urgent.
You simply cannot ignore the physics of hauling something this heavy. The vehicle's chassis has to have the correct gross vehicle weight rating, or GVWR, to support a fully loaded tank safely. Because if you overload a truck, you aren't just wearing out the tires faster, you are actively destroying the suspension system, and you're outright violating Federal Highway Administration compliance laws for commercial vehicles. The consequences here, both mechanical and legal, are severe.
So, how do we make sure we get this right? It really comes down to matching capacity to the chassis. Think of this as your cheat sheet. If you're doing landscaping or squeezing through narrow city streets, you want a 3,000 to 5,000 liter tank on a compact chassis for maximum maneuverability. For standard municipal work or construction, you're going to step up to an 8,000 to 15,000 liter tank on a medium-duty chassis to properly balance that payload. And if you're in mining or hauling water over really long distances, you absolutely need a heavy-duty, multi-axle chassis that can support 15,000, 20,000 liters or more. But here is a massive mythbuster for you. A larger tank is not always the best choice. I know, it is so tempting to assume that when it comes to commercial equipment, bigger automatically equals better. But in the world of water trucks, that is a trap.
The size you actually need relies on a pretty delicate balance. You have to factor in the chassis GVWR, the axle ratings, the tare weight, which is just the empty weight of the vehicle itself, local regulations, equipment weight, and your distance to water refill points. See, more water capacity means more vehicle weight, which actually means less payload flexibility. If your operational area has plenty of refill points nearby, a smaller truck is actually far more efficient on a daily basis. You only need the massive tank if you're traveling long distances between water sources.
All right, Section 4. Comparing tank materials. Building the right tank.
Now, what's really interesting about this breakdown is seeing the clear trade-offs between the three main materials. Carbon steel is your industry standard for things like dust control and street cleaning. It's got strong structural integrity and is super cost-effective. But yeah, it is prone to rust over time. Then you have stainless steel. This is strictly necessary if you're transporting potable drinking water because it's completely rust-resistant and food-grade safe. But you will be paying a higher initial purchase cost for sure. Finally, aluminum alloy. It is incredibly lightweight, which dramatically increases your available chassis payload for highway transport, but again, high cost, and it needs highly specialized welding if you ever have to repair it.
Moving to our final piece, Section 5, pumps and spray systems, flow, pressure, and control. You know, a really big mistake buyers make is just looking at the physical size of the pump. What you actually need to do is match your pump selection directly to your specific objective. On one side, you have high flow rates. You want to prioritize this if you need to distribute huge quantities of water over a really broad area, like suppressing dust on a massive construction site. On the other hand, you have high pressure. You prioritize this for targeted road washing, deep cleaning, or powering those long-distance water cannons. Basically, flow is all about volume, pressure is all about force. So the crucial point is, when you're comparing pumps for long-term success, you have to look way beyond just the footprint of the hardware. You've got to review the rated flow rate and operating pressure, the pump speed, and its self-priming capability. You also have to decide between a PTO or hydraulic drive configuration, make sure it's compatible with your spray system, and, honestly, perhaps most importantly, ensure you have easy access to maintenance and spare parts when you need them. And once your pump is dialed in, you have to customize your spray system to match it perfectly. A construction truck might just need a wide rear spray, right? While a landscaping truck might need side sprays and hose reels. You must specify your required spray width and direction, your nozzle types and discharge pressure, whether you want manual or remote valve controls in the cab, and exactly how many spray outlets you need. Oh, and a pro tip, straight from our source material. Specifying self-filling plumbing or suction equipment can drastically reduce the time your crew wastes just sitting around refilling the tank. When you finally pull all of these specs together, sourcing the right vehicle really demands a capable supplier. Take CNS Special Vehicle, for example. They provide customized municipal and industrial tank trucks that meticulously balance payload and pump performance. It's just absolutely crucial to evaluate a supplier's production capabilities to make sure the final vehicle actually meets your local regulations and specific climate conditions. Which brings us to our final thoughts. After looking at the hidden physics of baffles, the crucial balance of weight and chassis ratings, and the vital differences in tank materials and pump pressure, you have a choice to make. Will you overspec your truck for some rare what-if scenario and waste valuable payload capacity? Or will you use this knowledge to build the exact precision tool your daily operations actually demand? Thanks for joining me on The Explainer today. I really hope you're leaving here empowered and ready to put this new technical vocabulary to use. Keep learning, and I'll see you next time.